What's up, my fellow programmers, software developers, software engineers, future engineers? So today we're actually going to be covering Chapter 5, which is Class Design Guidelines. This is in the book, The Object-Oriented Thought Process. So far, it is a great book, so if you haven't got it, go get it. Okay, so anyways, let's get started. Okay, important note, this chapter is meant to provide a guideline when designing a class. Obviously, there isn't any list that is ever 100% complete, nor is there an official standard list that everybody agrees on. My recommendation is to try it before you decide not to use it. Okay, so let's start. Notice my whiteboard. Hi. Okay, anyways, so back to the topic. This is actually a very short chapter. The next two are actually. This is modeling real world, if I could talk. Modeling real world systems. In object-oriented programming, the objects contain all the functionalities and the data. The main goal is to build classes which contribute to the system while containing their own data and functionality as encapsulated as possible, and making classes as independent as possible. Okay, so basically what we're trying to do is we're trying to be able to make classes we're trying to make classes that are reusable. We're trying to build classes that have a purpose and that actually play a part in the whole system. It's not just lingering around. Okay, so now the minimum public interface. The goal is to only provide the minimum interface needed to do the job. The users of the system do not need to know how it works. Okay, so remember, just keep the public interfaces at a minimum as possible, enough to do the job and not more. The users do not need to know what code and how it was executed. All they need to know is that they're able to do it. Okay, so next is hiding the implementation. As stated above, hide all of the code which is not needed. Do not allow other objects to have access to the code which they do not need. Private methods will only be accessible to other objects through public interfaces, and public interfaces must be kept at a minimum. Okay, so it's the same thing. We gotta hide the implementation. If you guys don't necessarily know how, let me see if I could show you guys a quick example on the board. So basically okay, so we are not focusing on the code or the syntax of the code. All we're trying to learn is the concept, okay? So I'm not going to write with perfect syntax. I'm not going to spell right, no keywords, basically just a function. The method, I'm sorry. Okay, so basically this will be a private method. This will be a private, meaning that it's not accessible to other objects, right? It's private. It's only able to be used within this class. And this is public. This is basically the class that all the other objects will be able to instantiate. Now, in order for anybody to instantiate this private class, the handle of this class has to be within this public. Of course, it's not going to be private. It's going to be whatever name you give it, right? Because you instantiate it. Now, notice how we close it off here. The code is here. The code will be here. So basically the application doesn't care what is going on within this class. What the system cares about is that this class actually provides the data that it needs to public. So in order to keep working. Okay, so next we got designing robust constructors and perhaps destructors. One of the most important design issues involves how the class will be constructed. A constructor should put an object into an initial safe state. This includes initializing all of the attributes and memory management. Make sure the object is constructed properly in the default condition. Destructors are used to free memory once the object is destroyed. Some languages do not handle garbage collection automatically, which can cause memory leaks, slow the system down, and eventually crash the system. The next is designing error handling into a class. The general rule is that the system should never crash. The ideal situation is to create systems which fix and continue running if an error ever occurs. If that is not an option, the next best thing is to exit gracefully without losing any data the user had not saved prior to the crash. So this is where we talk about the try catch blocks, the conditionals. This is where we want to catch it and we want to be able to fix it or exit gracefully. Okay, another one is using iteration in the development process. In order to avoid a whole bunch of errors all at once, we should test the code in small iterations. This basically means that every time you create a change in your code, you gotta make sure that you save. Okay, Control S is your friend. Control S. You can also Control Alt S, which is save as, but you know, same diff. Tomatoes, tomatoes. Okay, next is testing interface. Creating bare-bone methods or classes to test before adding code is perfectly fine. Minimal implementations of the interfaces are often called stubs. Stubs usually do not contain any code and are meant only for testing. So this is basically small methods or interfaces which you get to plug in so you could just make sure that the data is crossing from one to the other, that you're getting the result you want. Next is documenting the class and using comments. Now, this is the one I do not like. Documentation, but we all need to do it. Okay, so documentation and comments are very important when it comes to creating a system which will go through different development phases, especially if multiple developers are going to work on the same code. Create documentation and use comments. Remember, if we do not create no documentation and we don't comment our code, we might not know what we're thinking of or what the logic was behind the code of which we wrote. So if we don't comment it and we leave it and we come back to it, we might not remember why we did what we did. Now, next is building objects with intent to cooperate. Rarely do classes live in isolation, and in most cases, there is no reason to build a class if it is not going to interact with other classes. A class will serve other classes. It will request a service of other classes or both. So that was pretty obvious. There's no point in creating a class if we're not going to use it. And if we're not going to use it, then why create it, right? If it's not going to interact or if it's not going to contribute to the system that we're building, why even have it? Pretty straightforward. Okay, so next is naming convention. Whoops. Anyways, in order to achieve consistency, create a proper naming standard and stick to it. Picking the naming convention isn't quite as important as sticking to it. Make sure you use a descriptive name and consider using plurals, verbs, nouns, camel case, snake case, etc. for different things. Okay, so standards. You need to have coding standards. Okay, next is abstracting out non-portable code. Code will not be supported across all systems should be abstracted into its own class or at least contained in a method which could be overwritten. Non-portable code should never be in a primary code which is dependent of the whole system. This is where wrappers come in very handy. Okay, next, providing a way to copy and compare objects. The benefits of creating a deep copy of an object with the current state is that you can modify the copy without affecting the original. Okay, next is abstracting out non-portable code. Code will not be supported across all systems should be abstracted into its own class or at least contained in a method which could be overwritten. Non-portable code should never be in a primary code which is dependent of the whole system. This is where wrappers come in. Okay, next, providing a way to copy and compare objects. The benefits of creating a deep copy of an object with the current state is that you can modify the copy without affecting the original. The difference between shadow copy and deep copy is that a shadow copy contains only a reference of the data and functionality, while a deep copy has allocated memory of its own. Okay, so the next is keeping the scope as small as possible. Keeping the scope as small as possible goes hand in hand with abstraction and hiding implementations. The ideal is to localize attributes and behaviors as much as possible. So only initialize variables within the scope that they will be used. Well, that's a good practice. Okay, next. A class should be responsible for itself. Although the parent class can provide methods for the classes they extend, children classes should be able to override some methods to polymorphism. Consider the shape class example in chapter 2. So, okay, next, designing with maintainability in mind. To create maintainable code, we must try to build abstract methods in order to be able to change the implementation without creating a domino effect across the system or a class. Okay, two more. Using object persistence. Object persistence is the concept of saving an object's current state in a storage device. In its simplest form, an object can persist by being serialized and written to a storage device. The three main primary storage devices are flat file systems, relational databases, and object-oriented databases. XML may be used to save an object's current state. Okay, so last but not least, serializing and marshalling objects. Serializing is the act of deconstructing an object, flying it out, and marshalling is the act of sending the object over a network and then reconstructing it on the other end. It is important to implement encryption in order to prevent security issues. So that is it for Chapter 5. Hope to see you guys next time.